All right. Well, thanks for being here. Today we'll talk about working with strings and characters, and we'll introduce regular expressions, which I think is really exciting. Yeah, I've got a lot of slides. We're not going to cover them all. We'll look at this slide deck between today and on Friday as well. So. All right, so probably so far as work you've done in statistics has primarily been numeric, right? You start off with things like finding the mean and plotting regression data and things like that. But a lot of times these days we have to work with text data, and there's kind of like emerging and whole new areas of statistics and machine learning that are devoted for interpreting and learning from text-based data, such as textual data analysis, linguistic analysis, text mining, sentiment analysis, natural language processing. And text-based analysis is kind of beyond the scope of our course. We could probably have an entire course on text-based analysis. And you can actually minor in digital humanities at UCLA these days, which will do a lot of text-based analysis. But there's a few resources here. Tidy Text Mining is basically a textbook that you can just read online. Of course, if you want the printed version, you got to pay for it. But the entire textbook, the content of the textbook is available for free to read on that website. Okay. There's also a ton of packages that have been produced for R as far as text mining and working with text data goes, and that's all available on this thing. And as you might have to learn or want to learn Python and things of that, other languages for working with text data, those are popular choices as well. Here's just a lot more resources. There is Handling Strings with R is kind of like its own little mini book in itself. The R for Data Science textbook also has a chapter on strings. And again, this is an excellent textbook, and you can read the entire textbook online. And there's a chapter on handling string data. There's different books, the R programming book on text processing, even just the help file for the Stringer package, which we'll take a look at today, is quite useful. Some cheat sheets for Stringer and regular expressions, very useful. And then later on, we'll cover learning regular expressions, but really the best way to learn is to be able to test them out. And these web pages allow you to kind of test out your regular expressions. So these are really great resources that you should check out. Okay, so let's just get started and talk about characters in R. And so, anything that represents kinds of text and word, we call those characters. And I use the phrase character and string, character data and string kind of interchangeably. And basically when you print characters in R, so here X is going to be the character string hello world. And when you print that out, R is going to print out this little vector, square bracket 1 vector indicator, and it's going to say, yep, it's a character, and it puts quotes around it. And if you say, well, what is the type of this X? It's going to say it's character. Okay, and the answer, the result of type of X itself is character data because it's in quotes character. Okay. You can create strings using just the quote marks. You can use either single quotes or double quotes. And either of those work. And if you use double quotes, you can include single quotes in your thing. If you use single quotes, you can include double quotes in your thing. So here I can write, this is the quote, single quote R language inside here, and it will output that. For whatever reason, when you knit into with LaTeX, LaTeX replaces the single quotes with kind of these curved apostrophes, which is technically not the same, but just pretend it's a straight single quote. Okay, and here if I enter this single quote, straight single quote, double quote here, this will also remain one character thing, and it puts in a it escapes the quote marks that I put in here. Okay, and you know, if you tried to use double quotes inside a double quote, this is going to return an error because this double quote closes off this double quote, and this, R doesn't know what to do with this, and this double quote gets paired with this double quote. So if you try to enter something like this, you're going to get, you know, it's going to come back with an error. And so that's why, you know, when you look at this, it escapes. This is what we call escaping it. It puts a backslash in front of it and just says, you know what, this doesn't take its normal meaning of a quote character. When you create a character vector, kind of the default value is the empty character. The empty character is basically there's no character between the opening and closing quote. Okay, so the empty character gets represented in R as quote quote with nothing in between. Okay, this is character data, but there's no value in there. So if you say character 5, it produces 5 empty characters here. Okay, the empty character is not the same as character 0. Character 0 is a character vector of length 0. Okay, the empty character by itself in a vector is equivalent to character 1. Character 1 would be a character vector of length 1 with an empty character in there. Okay, and so this, the empty character is equivalent to this. It is not a 0 length vector. Okay, 0 length would be character 0. There's nothing there, but it's type character. Is that all right there? The paste function. The paste function is used for creating and building strings in R. Okay, what it does is it takes the objects, it's going to convert them to character type, and then it's going to paste them or concatenate them together to form either one large string or several strings. Okay, and the basic syntax is paste. You put in your objects, and then you specify a separator character, and then you specify a collapse character. Okay, if you want to. Okay, paste 0 is the same thing as paste, except the separator character is the empty character. Okay, and so that's what paste 0 is. So here's just a few examples. Here I put in three vectors. Each vector has a length of 1. And so I have the character I ate some, the number pi, and another length 1 character vector, and it was delicious, and it produces this. I ate some 3.1415926535879879, and it was delicious here. Okay, and this is a character vector of length 1. Here I've got bears, beets, Battlestar Galactica. The separator is comma space, and it produces a length 1 character vector with bears, comma space, beets, comma space, Battlestar Galactica. Here I have a length 1 character vector H. I have a length 3 character vector with the elements A, E, and I. And the separator is going to be there's no separator character. This produces a length 3 character vector, HA, HE, HI. These are 3 separate elements. This is a character vector of length 3. Right? Here I've got a length 3 character vector ABC. And here I have integer vector 1, 2, 3. And if you say paste, it's going to paste these element-wise. So it produces A1, B2, C3. We've got 3 elements in this resulting vector. Is that okay? All of these, I haven't done any kind of collapsing. This one, I will collapse. Okay, so here, this is very similar to this. Okay, I've got A, the integer vector 1, 2, 3. And so if I didn't specify collapse, it would have produced A1, and then the second element would be A2, and the third element would be A3. But here I said collapse them, and so now we get 1 character entry. These are not separate entries, okay? And I've got A1, comma, space A2, comma, space A3 as 1 character value here. This is a length 1 character vector. Okay, does that make sense? The difference between the results of paste here and the results of paste here using the collapse. Okay. If you're doing any kind of partial recycling, it's not going to throw a warning. Okay. How do you paste ABC and 1, 2, 3? Yeah. So that's basically what we have here, right? How will this? I think this is your question, Hal, or is yours different?
I would say the second argument as a vector of 1 through 3.
Yeah, so this is equivalent to the vector 1, 2, 3. Or no? So you're asking, I've got this, right? And you're asking, what if I put this inside here? Okay, that's going to be exactly the same. If I put in a space, I can get that. And then if I do collapse, then it, instead of, so this is length 3, and this is length 1. All right, a few functions as far as outputting stuff onto the screen. Oh, before I get into that, let me give you, did I already give you your first quiz answer? No. First quiz answer is D. D as in dog. D as in dog is the first quiz answer. D as in dog. Okay, so let's look at a few kind of functions that can be used to output strings. We have print, we have cat, we have format. All right, and so print will output stuff. I think we're familiar with it. There's a few options. You can print quote equals false. So if I were to take the results here and put it into y, okay, here I get this, but I could do print y and the quote equals false, and then it prints out y without quotes. Okay, you can also do no quote y, and it will also print it out. The thing about here, y remains a character object. If I do no quote y and I save it as y, then y will retain kind of its no quote property here. Okay. So that's kind of the difference. No quote outputs a no quote class object, which if you use in the future will kind of retain its no quote property, but it's still a character thing, right? So if I say what is a class on y, it will say no quote the type of y, it's still character type. Okay, cat will just output whatever you give it, and it outputs it onto the screen. Okay, you can give it things. There's a kind of a default separator, but here I'm going to specify the separator to be comma space, and here it just outputs onto the screen. One thing to note is that the output of cat doesn't have our single square bracket to indicate that it's like vector type. Okay. And so there's no quotes that appear. And the result of cat, like cat does not return an object. It doesn't return an object. And so it technically returns an invisible null. So you can't kind of assign the result of cat to a variable. Okay. But one thing about cat that you can do is you can use cat to write files on your computer. So you can say, you know, I want the output of whatever it is that we're doing, I want it to kind of get output to this file. And you can also specify options to either say, I want to append to an existing file, or I want to just overwrite the existing file and things like that. Okay, so cat is that you can not just output to the screen, you can output to a file. And there's always just more arguments and stuff that you can look up for any of these functions. Format allows you to kind of take control over how the character strings get handled and output. And so there's a few arguments. One is you can specify the width of the strings that get produced. Okay. And you can also trim any extra kind of spaces padded spaces on the output. And you can also justify, which is going to kind of take control where the spaces go if you're kind of in conjunction with width. Okay. Digits, as far as printing out numbers, digits can be used to specify how many digits you want to appear, or the kind of the number of places and scientific and all of this kind of stuff. So I think this will all make a little bit more sense, when I show you a few examples here. So here we're going to just do 1 divided by 1 through 5. And so that's going to be things like 1, 1/2, 1/3, 1/4, and 1/5. But digits, when you do format digits, the output, everything here is character type, right? So format will turn everything character type. And we can see that all of these things, it kept 2 digits. Here we're going to say digits 2 and scientific is true. And so here it kept all of, basically the same information here, but everything is in scientific notation. Okay. And then here, I'm taking these character strings, and so I got hello world, hello universe as 4 separate entries in this vector here. And we're going to say, I want to format these so all of the things that get produced have a width of 10, and I'm going to left justify them, okay? And so this is going to put the spaces after hello. And so I have kind of 5 spaces here, I've got 5 spaces here, 5 spaces here, and I've got 2 spaces here, just to kind of do that. And, if I were to do this and do, say, something like justify right, it puts the spaces on the other side there. Okay, or justify spell the center like this. Yeah, there you go. Okay, and here it puts the a space on each of these things in case you wanted to kind of output this in some way, right? Center is spelled this way. All right, you can kind of manipulate strings, and these are kind of functions that exist in base R. There's number of characters to lower to upper, translate the characters, substring, split, sorry, yawning, boring myself here. Okay, so number of characters will tell you how many characters we have, so we can do hello world, hello universe, 5 characters, 5 characters, 5 characters, 8 characters, okay? Turn everything lowercase, everything's lowercase. To uppercase, everything is uppercase. Okay, so no surprises here. You put in a vector, it outputs a vector. Character translation, char tr. This says replace all capital H's with a Y. Okay, so here my vector is this. We're going to replace all capital H's with a Y, and it produces yellow world, yellow universe. Okay, here we're going to say replace E with a 3, L with a 1, I with an exclamation point, and O with a 0. And then so hello world, hello universe becomes this, right? So this is, I don't know, this was at one point maybe how people wrote stuff to each other online just to be kind of silly. And this is what we had, right? So hello world, hello universe. And so this is just a one character to one character type of thing. So it's kind of like if you wanted to like, I don't know, make like a little cipher. Like, I don't know if you ever played with this as a kid and you wanted to like make a secret message, you could translate every character to something else, give your friend the decoder thing, and do it, right? Is there a quick way to quickly make the first letter of a character upper, everything else lower? Not quickly, no. You can just kind of there's not like that kind of case thing in R, but I mean, there's a way to do it, but not in a quick fashion. Okay, you would have to probably substring it and then do the first string to first capitals and then paste them everything back together. So, quick question on format. What if the added number of spaces is odd and we choose center? Yeah, It's not perfect. So in this case, I have 2 spaces on this side of world and 3 spaces on that side of world. So this here I chose justify center, and I've got 5, and so 3 ends up on this side and 2 end up on this side. And it seems like it applied that universally. So kind of close to center, but not perfectly so. Okay, substring says, give me back just a part of the string. So X was hello world. And here it says start out the second character, which is the E, and go to the 9th character, which is the R. Here we say take hello world and split at the space, and it returns back a list and the first element of the list. Because X is a vector of length 1, if we get back a list of length 1, and we get hello space, and then another element in the vector world. Okay, it was split at the space. Now you could specify other characters to split on. So you could say hello world split on the O, and then it will take hell, and then it does space W, and then it splits on the O, and then we get RLD. All right, let's start looking at stringer. Okay, string-R is kind of is a tidyverse package for string manipulation, and you can load up with library tidyverse, or you can load library string-R. And what it does is it handles kind of R string functions kind of consistently, and it does a few. It's really great. Okay, so a lot of these functions, similar functions exist in R, like paste, and you know, a lot of these things do exist. You can do grep and gsub, but stringer does them well. So I strongly recommend them. Okay, this slide got formatted funny. This should have appeared as a list here. We have string C for concatenation. So this is kind of like paste. String length is similar for number of characters. String sub is similar to substring. String duplicate will duplicate characters. String trim will remove leading and trailing white space. String pad will pad a string, and string wrap will wrap string into a paragraph. Okay, and we'll take a look at some examples of this. And there's slides that you can read, or pages that you can read online. So so here's an example of how paste and string C behave a little bit differently. So the base function is paste, and if you throw in null or character 0, paste is going to do this, right? So here X is the string hello world, and here I've got null, character 0, 0 length character vector hello universe, and it gives me comma, space, comma, space, comma, space. Like these are all 0 length, and I'm saying my separator is comma space, so it kind of does this, but you know, this looks a little funny. Whereas string C recognizes these as 0 length and doesn't even bother including them. And so we get hello world, hello universe, which is kind of a nice feature, right? The default separator for paste is a single space, whereas the default separator for string C is the empty string. Okay, string length works just like n characters, except it also works on factors. So if you do take month names and throw them in a factor, n character can't do it. Okay, whereas string length will, it'll say, oh yeah, you know, these are factors, but I recognize that a lot of times factors look like strings. And it says, you know, January has 7 characters, February has 8, March has 5, April has 5, May has 3, June 4, July 4, so on and so forth. So the longest name is September. Okay. So let's look at regular expressions now. Okay, let me give you your second quiz answer. Second quiz answer today is B. B as in bear, or yeah, B. B is the second letter of the alphabet and our second quiz answer. Okay. We're going to do pattern matching, okay? And regular expressions allow us to kind of describe patterns that we want to match. Okay, and there's a lot to cover. I'm going to give you a lot today. I'm going to give you a lot more on Friday. And the best way to kind of learn regular expressions is to just practice them. I don't know how much exposure you guys had with regular expressions. So I asked the other class who's seen regular expressions, and you know, a fair number of them have in different kind of coding classes like Pick 16 and stuff, but different ways here. Okay, so you know, these are some things you can do. You can like check if a phone number looks good, or if a date entry looks good, or email address looks valid. You can check if your password has the right number of, you know, numbers and special characters. You can look for alternate versions of spellings of words. You can look for instances where the word analysis is followed, you know, preceded by the word data, computer, statistical, or things like that. Convert a comma delimited file into a tab delimited file, things like that. Okay, there's all sorts of things you can do with regular expressions. It's pretty great, and they're universal. So whether you're doing work in Python or R or some other language, JavaScript, things like that, what you spend learning regular expressions here will be applicable to these other languages. They're kind of, everybody has kind of accepted these regular expressions. Okay, and so R has native regular expression handling capabilities, but the stringer functions I think are better. And so they're kind of in this family. We have string detect, string locate, string extract, string match, and string split. Okay, string detect returns trues and falses if it finds a matching pattern. Locate will give you the location. It finds the first pattern, first match, and it will give you the index of the first character that matches, and then the index of the last character that matches. String extract will kind of pull out the matching text that matches the pattern. And then later on, we'll learn about capture groups, and string match will pull out the capture groups. String split can split things into different vectors and stuff. All of these things kind of match the first location, and underscore all will give you kind of, we'll find all of the matching patterns, okay? And they're all in the form of, you take a string, the first argument is the string, and then the second argument is the pattern that you were trying to match, okay? So the simplest will be literal characters. Simplest type of pattern is just literal characters. Anything that includes kind of just the English alphabet and numbers will be literal characters, and they will kind of just match themselves. So just matching these, right? So here we can say, search this string, I love stats, for the pattern STAT, okay? And it's going to find it right here. And it's going to say, okay, I found it at the 8th character. So it starts off, I is 1, space is 2, L is 3, O is 4, V is 5, E is 6, space is 7, S is 8, T is 9, A is 10, T is 11. So it starts at 8, ends at 11. But if you have I love stats with a capital S, it's going to say it finds no match. There's no start or end value that matches lowercase STAT. Okay. String locate only finds the first instance. So here's my string. I love statistics, so I am a stats major. And if we say, okay, search the string love stats with STAT, it's going to find it right here, STAT, and that's going to be characters 8 through 11. String locate all will locate this STAT 8 through 11, and it's also going to find it over here for stats major. So I'm a stats major, and it's going to find 2 locations. And so what it returns, will it return a list with a matrix, and it's going to find the location and start and end of the first, which is 8 through 11. And it's going to also, on the second line, return the start and end of the next location, STAT. Over here, the second 30th character to the 33rd character, right? And so that's the difference between string locate and string locate all, okay? This is, you could have a vector, right? So here I have love stats is a length 1 vector. Okay, but let me just, we could, if I make it a length 2 vector, okay, then these things will return, so string locate will return a matrix with two rows, okay, because it does it for the first one, 8 and 11 and 4, 7. And then string locate all will return a list of length 2. The first will be a matrix with 2 rows, okay, because it's finding it in here. And then the second will be a matrix with just 1 row because it's finding it in ABC stat here. Does that kind of make sense? So I'm getting the results there. Okay, so as far as we have to go, meta characters are what's going to make regular expressions interesting and powerful, okay? And so these are all the meta characters that that exist in regular expressions: the dot, the caret, the dollar signs, asterisk, plus, question mark, and all of these braces: curly braces, square braces, curved braces, along with the backslash and bar. Okay, so these are meta characters. They do stuff. So the first meta character that we'll cover is the dot. The dot or the period is the wild card. Okay, and this will just match any single character except a new line. Okay, so here I've got this vector, not note, not nut. Okay, and here we want to say, do you detect this pattern n any character t, any character t? Okay, and it's going to say, yeah, n any character t, n any character t exists, n any character t exists, and n any character t exists. Okay, so we get true, 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 true. What about this pattern? No any character, no any character. Does that match? And it's going to say, yes, no any character, no any character. For not with a K, it's no matches with any character. This, there's no match. We have an NU, so that's not going to match this, okay? It doesn't match the NO part, so we get true, 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 false, okay? Here I got the vector 5.00, 5100, 5-00, 5 space 00. And I apologize for this. It says, what will, if the pattern is 5.00, what will this return? 5.00. So this will match all of them, okay? It's going to match the 5 any character this, it'll match the dash, and the 5 any character 00 also works because the space is any character. It's going to match anything other than a new line. If you want, okay? So the meta character stuff only applies as far as the pattern goes, okay? As far as what happens in the text that you're trying to match, it's always going to be literal stuff. Can you match multiple dots? Yes, you can match multiple dots, and it's going to be any character, right? So you can do multiple dots, and every dot represents just any character. But we'll also look at quantifiers where you can say, like, I want multiple of a certain thing. Okay, so here, the text that you're trying to match will always be literal, but if you want to match a literal square bracket inside the pattern, you have to escape it. You have to tell the regular expression engine, or in R, that you are trying to match the literal square bracket. So here, if I say string detect, try to match, and there's a square bracket here, try to match the square bracket, it's going to get confused. It's going to see this as a meta character, and it's going to say, well, I don't know what to do. Whenever I see this, I'm expecting a closing square bracket, and I don't see it. And it says, you know, regex missing closing bracket. That's a problem, right? So here you have to say, I need the literal square bracket. And you do that by escaping it with a backslash. But because the backslash itself is a meta character, you have to use a double backslash, okay, as far as regular expressions in R goes. This is not how it works for other languages. So other languages, you just use a single backslash and it works. But as far as R goes, you need a double backslash, okay? So we do double backslash square bracket, and then it will say, ah, yes, I see the literal square bracket inside of here. And that says true. Okay, and so here is, this was the example 5.00. We'll match all of this because this dot is a meta character. If you want the literal dot, you can do 5 and you escape out the dot. So backslash backslash dot. And this will only match the first. This is a true and everything else is a false. Okay, whereas this one here, this is a meta character, it's going to match all of them and we get trues for all of these entries, all 4. All right, so far so good with everybody? Okay. Square brackets indicate a character set, and this will match. This says a square character set indicates one character, but it could be any one of the characters in here. Okay. So here I have match. I've got this vector pan, pen, pin, p0n, p.n, pawn, paun, pwn3d, and happiness. Okay. And so here we've got p square bracket AEIOUN, okay? And so this says, tell me if it matches p one character and one character of either A, E, I, O, or U, and then N. And so what will it return? It will match pan, it will match pen, it will match pin because this is P one character N, and they're all either A, E, I, or O, or U. Will it match P0N? It will not, okay? Because 0 is not one of these characters. Will it match P dot N? It will not, okay? The dot here is a literal dot. The dot, it's not that this is a wildcard and it's trying to match over here. The dot is a wildcard only in the pattern. Here it's a literal dot. What about this, P-A-U-N? Will this match? It will not, because here we have 2 characters and this represents only 1, okay? There is a way to say, even though A and U both appear in here, this will not match because there's 2 characters, okay? What about this, PWN pwned? It will not, because W is not one of the 5 characters here. Will it match? Will it find a match in happiness? It will. It will find the PIN here, okay? So we're going to get true, true, true for these 3. Okay, we're going to get false for everything from here to here, and it will find the pin in happiness. Okay. You can define all capital letters as A, B, C, D, F, G, all the way through Z. It's kind of inconvenient to do that. So you can specify a range and you can just do square bracket A through Q, or square bracket, you can do little a through Z and capital A through Z. And this will match basically all 52 letters in the English alphabet here, okay? And so, so you can establish character sets this way as well. So you can do A-Z to get A through Z, right? And you can also do it with digits 0 through 7 and things like that, okay? So here the dash meta character will specify a range of characters. So how can we match 3 digits, 3 adjacent digits? Okay. Well, we can say we want to match 0 through 9. Okay, 0 through 9. And if we want to match 3 of them in a row, we can do 0 through 9, 0 through 9, 0 through 9, each of them representing 1 character each. Okay, and so this will match 1, 2, 3. It will not match these. Okay, there's only 2 here, so it will not match there. But it will match this. It will match the 890. It reads left to right, so it's going to match the 890 here. And so we get a true. Okay. This will match 3 adjacent lowercase letters in a row. We will cover more examples in the future where we, instead of having to write this 3 times, you can write 0-9 and then say, I need 3 of these things. Okay, and there's a way to specify that. You can specify. Question?
So why would, could you go back to the last slide?
Yeah.
So why would the last matching be true, but the second to last one is not?
So here there's only two, because it says I need a character between 0 and 9, another character between 0 and 9, and another character between 0 and 9. And there's only 1, 2 here. There's not 3 numbers. Okay. And here it will match because it says, character between 0 and 9, yes. Character between 0 and 9, yes. Character between 0 and 9, yes. And so this will match because we have 890. And this will not match because it goes character between 0 through 9, yes. Character between 0 and 9, yes. Character between 0 and 9, no, that's not a match. So it doesn't get a match here. Is that okay?
Yep.
All right. You can specify a negative character set, which will say, I need one character as long as it's not one of these things. Okay, as long as it's not. And so you use the caret here. The caret meta character will create a negative character set. You put it at the front of the square bracket character set. And so if you do this, square bracket caret AEIOU, it says I need one character as long as it's not AEIO or U. It does change meanings depending on whether it's at the front or the end. So here, this will say, I want a character that's not a capital letter A through Z, right? I want a character that's not a capital letter A through Z. So is this a match, yes or no? It is. This is a match. This is a match. What about this? This is not a match, okay? So we're going to get true, true. This is a false, and these are all true. These are all, so this is a literal caret here. This is not a literal caret. It is, this caret means not A through Z. Okay. On the other hand, if you put the caret here after the letters, okay, then it no longer takes its meta character meaning. And this thing says I need a character that is a capital letter between A and Z, or the literal caret. Okay, so when it's not at the front of the character set, then it takes on the meaning of a literal caret. Okay, so this we're going to get, we're only going to match this one, and we're going to match this one. Everything else will not be a match. This is not a match, not a match. This is a match, not a match, not a match. But this is a match. So we can see there is a match for here, and there's a match for here, but everything else is not a match. Okay, so what pattern means match anything except the caret? We can say, I don't want the literal caret, and use / caret. You could, this is actually optional, because if I just do caret, caret, the second caret would just be the literal caret anyway. Okay, so we could do that. And so this will say, I want anything except the literal caret, and we get, a match for all of this stuff, but not this one. Do we feel okay about that? All right. Okay, so let's try this. So when you put a meta character inside a character set, okay, it will often be kind of escaped. So this dot in here is actually going to be the literal dot. So this is AEIOU, or a literal dot. And so we'll get a match, 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 no match, and a match here, no match, and no match here. Okay, so here, this dot here takes on a literal meaning. Okay, so we do get a match for this, whereas the others are not a match. This is not a wildcard. If it was a wildcard, then it would have matched everything except this one, because I got 2. All right, so here, I wanted to do this, I could do that. I could do, so here, I could do P ... n, and this says I need 2 characters between P and N, and this would match pawn, PAUN. Okay. And this would match all of these except this one, because I've got just one character here. But here, as far as this goes, ADIOU or the dot, this is a literal dot now. And now it only matches, it matches these three, does not match this, it matches, but it matches this because of the literal dot. So the dot inside the character set represents the literal dot rather than the wildcard. So most meta characters inside character sets will be escaped. Exceptions are the square closing brackets, the dash, okay, because those establish ranges, the caret when it's at the front because it's representing a not set, and then the backslash, which is used for escaping. Okay, but most other meta characters inside a character set will be the literal character. We have shortcuts for establishing character sets. So if you need any digit, rather than having to do square bracket 09, you can also just do /d, okay? But again, because the slash needs to be escaped itself, it's gonna be /d, okay? /d is any digit. It's exactly equivalent to doing 0 through 9. You can say anything that's not a digit, so not 0 through 9, is /D, okay? And so the way to help you remember is the little letter is the thing, D for digit, capital letter is not that thing, capital D is not digit. Little w is a word character, capital W is non-word character. Little s is for space, white space, capital S is non-white space. Okay, word characters are basically things you can use for creating like a username on a website, okay? And so you can create usernames with, you know, little a through z, capital A through Z, the digits 0 through 9, and an underscore, okay? And so those are word characters. 0 through 9 and underscores are also word characters. And then non-word characters would be anything that's not those things. And then space is any kind of white space character. So that's a, you know, space, and you've got F and /N/R/T/V. Okay, and F is form feed, N is new line, /R is carriage return, /T is tab, and /V is a vertical tab. So on Windows computers, when you hit enter, it's going to enter a new line carriage return. So let me see. So if I turn on, so this is like my text viewer, and hit enter, I get carriage return and line feed. This is technically, so it doesn't look like anything, but when you hit enter, it actually is entering two things in here, carriage return, line feed. It's a little bit different on Unix based, so Mac is a little bit different. But a carriage return, so basically, if you think back to the typewriter days, you know, you're typing, and then the thing is moving across, tick, 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 and then you hit enter, and it rolls up the paper one line, and then you have to slide it back, right? So the rolling up is basically the new line, okay, line feed, and then the carriage return is sliding it back, and then you type, and then it goes tick, 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 enter, line feed, and then you carriage return pushes that thing back. Okay, so anyway, all to say, the /s is the white space class, and it's going to match any of these things, which is sometimes hard to distinguish in all sorts of different contexts. And you know, there's spaces and non-breaking spaces. I don't know if you guys are familiar, but so like here, this is. So non-breaking space. So normally you can say like, I live in the city of Los Angeles, and I love it. Okay. Right. And then as you increase this, right? So notice that the word Los and Angeles will get kind of split here. You can create something called a non-breaking space. How do I do this? Is it shift space? No. Control shift space. Okay, so a non-breaking space, which gets differentiated with this, will not allow these two words to be separated. Okay, so if I increase my font size here, it will go. It's even though the LOS could fit here, right? If I hit in LOS, it could fit there, but it's not going to let the Los and the Angeles to be split from each other. A regular space will, a non-breaking space will not. Okay, so subtle differences, and you have no idea what kind of space this is in here when you're just looking at it, unless you're looking at secret load. Then you go, oh yeah, that's a non-breaking space. So anyway, /s will detect all of these types of spaces here. Okay, we will continue on Friday with more examples of regular expressions. So we'll continue on Friday. Let me give you the last quiz answer. Last quiz answer is A. A as in apple. A as in apple is the last quiz answer for today. And we'll end here for now. And we'll see you guys on Friday to wrap up regular expressions. So have a good evening, and we'll see you then.